Good afternoon, and thank you for joining today's webinar from Spec Innovations, using Innoslate for model-based systems engineering. My name is Elizabeth Steiner, and I'll be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of the webinar. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. Today, he'll be showing you through the process of using Innoslate's modeling capabilities while applying a MBSE methodology. Dr. Dam is the president and founder of Spec Innovations. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4ISR architecture framework and DoD architecture framework. He has also received an expert systems engineering professional certification from MBSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. And now I'll hand over the controls to Dr. Dam and we'll get started.
Thanks, Elizabeth. We're going to talk a little bit about what we mean by MBSE, why there's a question in there somewhere, so we're going to ask why the question. Give you a little bit of the history of systems engineering to talk about, well, where did we come from? What are we trying to do with this model-based systems engineering? And then what do we need that's missing? Particularly, why isn't sysml enough? There are things that we should be doing, maybe beyond that. So, and also talk a little bit about the technology improvements that are going to enable better systems engineering in the future. And ask, why do we have to wait 10 years for that future? Because, in fact, Innoslate is the future of model-based systems engineering. So what do we mean by a model? So a model represents reality, but it's only a representation of reality. That means we're taking and abstracting it and simplifying it, because really to take the universe to model the entire universe completely. So we obviously can't do that. So we don't know enough about the universe even. So we gotta remember that there are always assumptions and that we're always doing something. That's where that famous saying by George Box is, essentially all models are wrong, some models are useful. The purpose of the models is to help us make decisions and to help us do a better job of building, buying, developing, using systems. So MBSE, according to INCOSE, is the formalized application of modeling to support system requirements, design, analysis, verification, and validation, beginning from the conceptual design phase and continuing through the development of later life cycles. Well, by that definition, MBSE has been around forever, right? We've been doing this kind of stuff for a long time. If you kind of focus in on those words, formalized application of modeling, we get a little closer to what I think people are really meaning by MBSE. But so what does this really mean to us? Well, what really the key to MBSE is what I call concordance. Actually, one of my colleagues, Dr. Vanneman, uses that term, and that's a good thing. And for those who aren't familiar with the term, it's defined right below. It says it's the ability to represent a single entity such that data in one view or level of abstraction matches data in another view or level of abstraction when talking about exactly the same thing. So in other words, you have configuration management you might think about for your modeling. That's perhaps another way to think about the whole thing. Well, there's a new DoD digital engineering strategy out, and they call this the single source of truth. It's obvious that, you know, there'll be multiple databases, there'll be multiple things, but ultimately you're trying to look in aggregation of the data from a single point of truth. What is the correct representative data that actually is what we mean by that thing and that we're designing? So from that model, the goal is to generate all the products needed for design and documentation throughout the life cycle. So again, that's the end goal of this MBSE, and trying to get us out of the paper world and out of even the pseudo paper world of Microsoft Office into being able to deal with the data at the data level and understanding it and working with it. Well, recently, a lot of people have been pushing sysml as the basis for MBSE. But is sysml the future of systems engineering? In fact, that question got asked. I was at a forum this spring at the Aerospace Corporation, and a questioner said, well, sysml is the current systems engineering standard, basically. But 10 years from now, it's likely to be something else. Well, so what's that something else? What's the future of systems engineering? What are we missing? Why isn't sysml enough if that's the case? You know, how will technology improvements better enable systems engineering? Why do we have to wait 10 years? And how can we predict the future? Well, it's easy to predict the future when we've lived it so many times in the past. So why don't we study the history a little bit? If we go back and look at the history of systems engineering, sure enough, a lot of people trace it back all the way thousands of years ago to the pyramids and some of these ancient wonders of the world that were just phenomenal. They could only have been designed and built systematically. There had to be some mechanism for doing that. And no, it wasn't space aliens. Okay, we really don't think that. By the way, I want to credit my colleague, Dr. Browse, Peggy Browse, who these slides are from. So it's from her course on Systems Engineering 505, which I teach as an adjunct professor at George Mason University from time to time. Continuing on in the history, you can go back to the machine age. Well, clearly that's the Industrial Revolution. Assembly lines required systems thinking, and that's a key aspect of it. So you could see that time frame, 1880s to 1945 roughly. You could see the amazing things that happened, particularly World War II, the amazing production that we were building and putting out aircraft in an incredible amount of short amount of time for the war effort. So that high volume of capabilities, things like that. But each of those were kind of single unit kinds of things you get your head wrapped around, and a single person even could kind of almost design it if they had to. Usually that wasn't the case. You'd have usually teams even then doing these kinds of things. But certainly by the space age, you know, the kind of systems engineering as we know it was born. And this is where, you know, we had millions of parts. We needed systems of systems thinking. You know, you think about where we landed on the moon. We had the launch systems, the communication command control systems around the world to capture that information and transmit it around. We had to have a lunar module, which was separate from the command module, and of course all the stages of the rocket. So I mean, all those things, of course, were just phenomenal kinds of systems engineering activities. And of course, one of the leaders was Ramo and Woolridge, which was the predecessor to TRW, Thomson, Ramo and Woolridge. And of course, they were considered often the founders of modern systems engineering. Well, today, complexity is really going out of sight. We're not talking gigabytes of information anymore. We're talking zettabytes. Yes, that's 10 to the 21st bytes. And so how can we deal with this much data? In fact, one of the big things that's being pushed is this whole idea of having a digital twin. Well, if I have a digital twin of an aircraft, here is an estimate by one person, Dr. Kirk Bourne at Booz Allen Hamilton, who's an expert in data analytics. And he was looking at what's the information set that you'd have to capture to really be capturing in a year all the information associated with that airplane. That's a zettabyte. So that's a lot of storage. I'm not sure we have a zettabyte of storage even in available today. So clearly we'd have to abstract even that right now. So even that goal is much longer term. So what's we done though in our languages in systems engineering? Well, in the 60s, we used flow charting techniques, particularly derived from software. That seemed to be one of the big things, although kind of simultaneously at TRW, this thing called SHREM was created for software and systems engineering, and had a key role in developing the ABM system at the time that went from cradle to grave in 3 years. It was amazing what that whole cycle They literally had the thing working and then turned it off because there was a treaty that told us to turn it, that we decided we'd go ahead and turn it off from. Of course, in the 70s, we had data flow diagramming. Jordan DeMarco particularly was one of the big ones. Warden Meller had some real-time extensions, things like that. Again, heavily influenced by software. That's pretty much, I remember using those techniques early on in my career, trying to get an understanding of that kind of flow charting and you know, even systems engineering kinds of problems, trying to adapt it to that. In the 80s, we had the IDEF, state machine modeling, computer-aided systems engineering tools were starting to be talked about. One of those was that I particularly was fond of was RDD 100. And anybody remembers that one? It was a workstation product that was really quite good. In fact, there's features that are pretty amazing, even by today's standards in that tool. But then we get into the 90s, and we have things like EFFBDs, which come out of the core tool. And same time, we started to see the object-oriented analysis and design / UML, which ultimately got integrated for those 3 different techniques into UML, Unified Modeling Language. Again, all of this, though, most of that's software oriented. Again, the EFFBDs are more out of that SHREM RDD 100 train lineage. So in the 2000s, sysml came out, 2007 in particular, as a profile on UML, but so again, focused heavily from the software world's point of view and trying to communicate with the software world. So finally, here we are in the 2010s, and right now it's still sysml, but there is something called the lifecycle modeling language that's emerged, and that's derived from systems engineering techniques. LML 1.1 includes an ontology for sysml, okay, so that the systems engineering can include that as well, all the way through a diagram entity level, all the way and instead of at the diagram level. So it's really looking at it from a data perspective, an ontological perspective, not from a diagrammatic perspective, which is the primary driver behind UML sysml. So that queries me is, why are we always kind of seeming like we're 10 years behind the software world? It hit me when I was thinking through this whole process after that talk, and I said, you know, there's got to be something. Why are we doing that? So what do we need that we're missing? That's what begs this question. So clearly we need methods to capture and visualize tremendous amounts of information. If we're going to deal with this level of complexity, we've got to have something that can deal with that whole problem. And of course, that requires massive storage and retrieval of information at a reasonable rate so that you can stand it. And it's not only the technical readouts, but also the programmatic information. Remember, systems engineering isn't just a technical discipline, it's a programmatic discipline too. We're optimizing cost, schedule, and performance for the system, just like the program manager does it for the program. And of course, both of us are involved with the risk and risk mitigation. So it's a critical thought that the programmatic side of this is integral to what we're doing in system engineering. And clearly, we need the capability to move data around easily between applications. That's certainly been a problem I've noted for at least 20 years, trying to move data from one app to another. It's hard to keep it consistent. It's hard to keep it, making it work together, particularly if I'm dependent on it. I looked at one point to do system engineering. I estimated I needed 6 different tools. That was not going to be trivial, and it was not going to be cheap. So, and of course, also we need a language that has decomposition and abstraction. And in fact, I think we need a systems engineering language, not a software engineering language. It's very different, you know, even though they both start with an S and an E, they are very different in how you look at things and how you do things and how you respond to things. And they need to be, because systems engineering has to optimize not only software, but also all the other disciplines. And there's a classic picture I have it sitting on my desk. I should have pulled it out and put it in this presentation, but it's a picture of a bunch of airplanes and what it would look like if different people designed them. And, particularly the aerodynamics people, the propulsion people, production, structures, guidance, controls, analysis. Didn't even have software on the picture. I mean, that's how old this is. But clearly, you've got a lot of different perspectives that have to be dealt with. And as a system engineer, that's part of my job. I'm supposed to be the honest broker between all those different disciplines. I'm not supposed to be just focused on software. So I know a lot of people are saying, well, yeah, I can do all that with sysml, right? Well, the problem again, sysml and UML, well, UML's peaked interest back in 2004. I don't know if anybody's seen this or not, but this is a Google Trends analysis. If you look at the words unified modeling language, the interest level has decayed exponentially. And I was surprised by that, to be honest. When I hired some software developers to work on some contract work, I asked them, well, how much UML, sysml kinds of things did you do in school? And he said, oh yeah, we had something on a class diagram in one of those classes we took. And I'm saying, okay, what school did you guys go to? Well, we went to Virginia Tech. Well, that's one of the top schools in software engineering, computer science. So if that's going on there, it's going on a lot of other places. So it has lost interest. And the reason is the software community said the software through pictures concept, which I still remember back from the 80s being attempted, just doesn't work. It doesn't work well. It's much easier to write the code, compile the code, execute the code, than it is to sit there and try to do the diagrams. Well, that harkened me back to my very first computer class back in 1971, where we were supposed to flowchart the code. And of course, it was much easier to write the code first than it was to flowchart it first. And so that's what everybody did. And because then we were doing it all by hand, but it isn't that much better today when you're trying to use Visio or PowerPoint for it. So since the software guys have moved on to something called Agile, and Agile is not Agile Systems Engineering. Please don't confuse the two. They're very different. And so people will yell at you if you try to confuse them in certain audiences. But so Agile in software requires functional requirements to get started. Well, where do you get functional requirements? Well, historically, we did it from functional analysis. That was where they came from. And so you can do that. Now, you could, of course, you can do this with object analysis too. I don't want to say that that's not possible. It certainly is. But oftentimes, you have to be very careful not to fixate on current objects in object analysis. And so that's where you start running into that problem. And so if you want to do a more functional approach, you want to take a more functional requirements approach and create those from functional analysis, functional diagrams. So again, sysml and UML require experts to create and interpret those diagrams. So that's another big problem I've run into, and particularly I ran into it big time with UML. We tried to use it on a big architecture program, and the customers were not happy, did not want anything to do with it. Very confusing to them, and they said, please get those out of my face. So we weren't communicating to all the stakeholders, which of course is a requirement for systems engineering. So if you must be an expert in sysml's lexicon and diagram specifications, who are you communicating with? I claim almost nobody. So why isn't sysml enough? It's worse than that problem. It's not than just being hard to understand. It's lacking maybe the programmatic pieces of information, risk, issues, decisions, schedule, cost, all those kinds of things that are kind of critical, and particularly as explicit diagrams or entities. And again, you can add those, of course, yourself, but then you're designing your own language on the fly, or you're responsible for that whole ontology. And so you're doing that the really hard way, if you ask me. So the lack of an ontology actually has been noted, and in fact, there's an RFP out for developing an ontology for sysml, and they estimate that they'll have one in 3 years. I don't know about you, but I don't want to wait. I've got many things to do between now and then. And well, but what if there's a language that already provides an ontology for sysml and fills in the missing pieces? Well, actually there is. It's the lifecycle modeling language, and you can go see it at www.lifecyclemodeling.org. So how will technology improvements enable better systems engineering? So there's certainly some emerging available technologies of the future. Cloud computing. Well, wait a minute, that's already here. Artificial intelligence. Well, at least part of it's already here. Natural language processing is already here, and we can use that. Graph databases, yep, here. And optical computing, soon. They keep telling us soon. I'm not sure that's going to happen my work time, but we'll see. So how can they help us? So cloud computing provides a means to collaborate worldwide today, okay? So you can work together as a team, and the systems engineering tools just need to take advantage of that capability. It's already here, it's already available, it's already in very secure locations, and it is available on classified systems even for the Department of Defense and other departments. Artificial intelligence, of course, can help us define design problems and potential problems early. Again, it can be an aid to us as analysts and users of it. Graph databases give us the greater storage capacity. And of course, graph databases are things like Google Bigtable. Amazon now has an equivalent of that they're putting out. So again, we're hoping to use that in the future ourselves. Optical computing, of course, again, will really speed up the computations and give us much higher level fidelity in modeling simulation. So why do we have to wait 10 years? Well, we really don't. As noted, most of these technologies really exist today. LML is available. It's an open standard. It's free for use. Please go ahead and use it. In fact, many people have. We've just recently seen papers on that from a variety of people. And it's designed to be the 80% solution. It wasn't meant to be a 100% solution. It was to give you a base language that everybody could communicate with, but everybody can have their own little dialects, and they can adjust it as they need to help, flesh out other domains. V&V, for example, might need some special things. Maybe in your particular operational environment, you need special language things that you want to make sure you have as well. So it's a simple language that was meant to be extended to meet your specific needs. Innoslate already uses cloud computing. It was designed for the cloud. It was originally put up on the Google Cloud. We're currently now on Amazon because, yes, Amazon won the cloud wars. So that's where we are today as our primary cloud provider. We also have that ability then, though, to put it behind firewalls, to put it into a client server environment. And we've even now gotten to the point where we can put it on a desktop for people. So it's much easier to go that way, by the way, than the other way, because the problem you have is latency. On cloud computing, that's a huge problem. You are not sitting right next to the computational engine that's producing a lot of the information. So you have to re-architect for that environment, and it's a significant change from a desktop tool, I can tell you. We actually started that way in our development of Innoslate and quickly abandoned it because it was clear that was a failure mode. So other tools are starting to begin to realize these capabilities and are migrating to the cloud, but they will run into some of those problems if they don't re-architect. The future of systems engineering is here because Innoslate already has all those features that people are looking for. So it's a full, so how is it the future? It starts with a full ontology, includes risks, issues, decisions, schedule cost. It has automatic traceability capabilities, automated diagram and document creation from data. You can use the cloud computing technology. And of course, we have AI and our natural language processing. So I'm going to hit all those briefly in slides, and then I'm going to have some time to show you the actual tool itself, so this isn't just slide view graph engineering. Full taxonomy. Okay, LML is extended for sysml in version 1.1. We also extended it for VNV. We added the test case subclass to action for that. In the LML, the only changes that had to be made was to add a port under the asset as a subclass of asset, and the equation for the parametric diagram. That pesky parametric diagram was had required its own new class because it is such a different container. The key is to think about this in language terms. The ND classes basically provide the nouns for our language, and since the NDs can have attributes associated with them, those are our adjectives. So again, from a linguistic point of view, you can see how that works, and it's easy to understand. They're simple names. We type them, okay, so you can have either an attribute, or we implement it as labels in Innoslate for each of these things. So an action can be an activity, it could be a task, it could be a function, whatever you want to call it. And again, you have the ability to add those labels and things like that to it to adjust it and sort and find things the way you want to find them. We actually use those labels a lot in things like our DODAF view pretty significantly. Of course, the other part of that is the relationships. That's the other aspect of an ontology, right? It's taxonomy plus relationships. And of course, the relationships are the verbs for the language. They give you that kind of action between things, between the nouns. And you can see an example here. This is a little bit, it is an eye chart. This is that table out of the specification. It actually is an 11 by 17 in the spec. So you can see why we blew up just a piece of it to show some of the relationships. And one of the keys is, in fact, that we have a decomposed by relationship for everything. So everything can be hierarchical, all the different ND classes. That's a key part of that ability to peel that onion and decompose the information and then be able to recompose it coming back. Because of course we have the inverse as well, relationships, so you have those. Of course, our relationships can also have attributes on them, so they're your adverbs. So now we've got, again, a very, very robust language. And people say, well, how can you do that simple taxonomy? How can that do everything? Well, of course, the relationships make it much more complex in reality. But again, there are ways to simplify that in the tool. What we've done is kind of hide those in an all tab of relationships, and you have pinned, so you can get this, or the popular ones, so you can get the ones you want to use most often. And so you can just kind of simplify this list so it's not so overwhelming to you. We thought that was a good way to implement it, so make it a little better user interface. Of course, on the automatic traceability, we have that ability to define relationships in both directions. So again, that gives us that automated reverse traceability. We currently now have a Traceability Assistant, which uses that NLP technology to help you make connections between different things, and that can happen with any relationship you choose. So again, it'll help you see where things should be connected. There's also a suspect assist as well. So if you've selected something, I'll say, well, that one's suspect because it may not really be connected, and what the problem may really be is that the information isn't in there to make the connection properly. If you want to do an impact analysis, by the way, of a change, there's also a spider diagram that can give you that too. So you see all the dimensions of traceability. It's not just a simple set of relationships. It's all the different possible relationships. So if you change something, it may impact all kinds of things, and the spider diagram lets you go through and find those things through the process. So it works with all classes and relationships, not just requirements. That's a very big point. So, because all these pieces of information need to be related to one another properly. Of course, auto generation is a very, very key thing, and you're seeing an example here of where it's going through and just we're selecting different things in the menu from where we are, and then those views are generated. So if I make a change one diagram, it automatically changes it everywhere. That is view generation being concordance. That gives us the concordance we're looking for. That's an absolute critical issue. Also, because we use the rule generation, we can, from one kind of diagram, we can generate all kinds of other diagrams. So all that information is already encapsulated. If you're using something and you go select a different diagram type, you will get the information that's related to that. Now, I've had a lot of people say, oh, well, really, I'd like to hide some of that. No, that's called an error. As soon as you start trying to hide data, you will lose concordance. And so that's a key part of this. So if you think you need to hide something, that's really probably a different model or a different diagram. So you really want to use that then in a different diagram and create that other diagram for that information. Same thing with the physical, lots of physical diagrams. I will say one of the things I do like about sysml is some of the IBD and some of these other diagrams are really pretty good and pretty useful for doing some of this physical modeling side of things. So again, it's just another way to view the information, pretty agnostic about what picture you like. The more important part is the data correct. And of course, another thing was document generation. We actually have a documents view now that's actually very, very robust. You can add your own document types to it. So you can organize your documents in any way you want. You can author all your documents in the tool. You also can embed live diagrams in the tool so that now, you always can keep them up to date and work that way. We actually can use that to do model-based reviews as well. You can set your review rubric in as a document type, send people a hyperlink to it so they go directly to that document, and then they can walk through that document and you can then hyperlink and select to those different diagrams. They can add comments to it. And so you can see, you can start building that whole idea of a model-based review fairly quickly and easily. Artificial intelligence, again, we use natural language processing technology, which is a branch of AI, to aid the user in the analysis of their models. Particularly, we started with the requirements quality checker. So we wanted to make sure our requirements were high quality. So we checked to see if they're clear, complete, consistent, if they contain design information, traceable or verifiable. Now I skipped over a couple, which is correct and feasible. Of course, those are things you need to think about as a human. Correct is it legal? You don't really want us going looking through all the law books in the world. I'm pretty sure that would take a little while. And then feasible is one of those, again, judgment calls. Is this even feasible to go this route? And again, that would require a lot of research to determine feasibility. So again, this is only an aid, and that's the purpose of it, to help you do a better job of writing your requirements, again, using these different techniques. The second one, AI tech, where we've applied NLP, is to the whole model. We actually have a set of 68 heuristics. They were given to us by research done at Naval Postgraduate School and Stevens Institute of Technology. Kristen Gianmarco is the professor that led that research, and it provided most of this to us and helped us make sure that we implemented the algorithms well. And so these are all tailorable, and the nice thing is that fix button. So when you see things like a duplication, it'll actually merge two things together for you, things like that. So if you accidentally duplicate information, you can easily find ways to fix it. And finally, the Traceability Assistant, which I mentioned earlier, which again is a new application of that. And we're going to take that Traceability Assistant probably and apply it to other diagrams, not just this matrix. So there are other ways to use this same kind of approach to enhance other analytical views in the tool. So Innoslate really gives us the cutting edge in systems engineering for the life cycle. We really now have the pretty much other capabilities people have been asking for, the model-based reviews, of course, I mentioned, workflow, fine-grained permissions with redaction, which is really quite cool. And of course, cross-project relationships, notifications, dashboards, on and on. They're just tons of different features and tools. But of course, nobody's happy. It's never enough. And we're not going to stop, because we are already starting to do the integration with design engineering tools. We're looking to that. We already have a CAD viewer, so we had started that path some time ago. Now we're going to deal with that a little bit more to help enable this vision for digital engineering DoD has. And see if we can't do something there. So our recommendation: use the tool of the future, not the past. That's Innoslate. So let me jump into a live demo now, And I want to also make some time for comments and stuff. So I actually happened to open up on our new DODAF dashboard. A few people may be interested in that. Perhaps the most interesting part to everybody will be this new timeline diagram view that we have. So the DODAF dashboard uses, again, labels to sort the different products. These are my most recently modified DODAF products. If I want to scroll down to see all of them, I can find a specific product by taking the list here. And so if I only want to see my OV1s, it will search and find just the OV1s associated with it, things like that. So then let me show you the and so you work with your different diagrams as you're engaging with it. And of course, oh, I see I'm signed out. That's why it's giving me the spinner. Let's restart that one. Should have checked it before. There we go. There we go. So by the way, here's my OV1 picture that was there. And yes, you can put backgrounds and pretty pictures and stuff like that in it, so you can make this look real. And of course, these are real objects within it. As I mentioned, there's a comments tab here, so you can actually comment about the diagram right here and have it be something that is tracked, and that shows up on our dashboard now. Let me jump back to the DODAF view here. CV3, so that's actually a timeline. This is our new timeline diagram. I'm still just getting used to it, actually. These are actions. So these are different actions that are occurring with the capabilities, associated capabilities. So so you can see how this was set up. It has a start date, a duration. I can change that duration by moving it. I can also add dependencies if there's a dependency. So I can add that dependency label as well, so it has that information. Again, very useful thing, like add milestones, track the different milestones. But what's kind of neat about this isn't just that, oh gee, it's a timeline picture, how cool. It's also that I can open an action diagram on this. So this is actually a process diagram now. I can go ahead and model this in more detail. I can decompose it, and it will come back actually with some of that information decomposition, and will show up on the timeline diagram. I can simulate it from here. So I can run my discrete event simulation. Play here. Sorry, I got to speed it up a little bit. This takes a while to run. There we go. And yeah, a few years. So again, this can be run in real time as well. So, but you can see it's scrolling through until it's going to finish up the last year and put that in. So there you go. You can actually engage this and do the modeling with it as well. So again, a nice tie-in to all those kinds of things. That's concordance. When you start seeing these different diagrams, it's the same information, you're seeing it different places in different ways. I can see it and work with it that way. So I think you'll find that concordance is a critical element of what you want in a systems engineering capability, and to do true model-based systems engineering, it absolutely should be doing that for you. You shouldn't have to be working. And there are tools that do it besides Innoslate. I'm not going to mention my competitors on my own webinar, but they're certainly out there and available. Some other things to show you the new dashboard. This is really pretty cool. You remember I said you can embed a diagram. Well, this is actually a real diagram. It's our risk diagram. Also another new diagram in the tool. It's been updated significantly from the last one. You can actually open the image in a new tab, for example, and what that's going to do is it's opening it up here. Take a second or so, and there it is as a picture. I also have a live version of it. Oh, that was open the image. Open the link in a new tab, and here it is that way. So again, this is the live diagram. I can go through and edit it, change it, adjust it. If I change and adjust it, it'll come back and update it here. So again, very useful. Other information you can capture, track your status of your top jobs, requirements here. There's a status thing here too. These are all tailorable. You can go in, change them. You can add other widgets on the dashboard. You can save it to the project, or you can make it available just for yourself. Again, these are tailorable at both levels. Also, the project comments feed. Here's the different comments. And again, anytime you see something, you just click on it and take it right to the thing and see where the problem is. Here's another place where I've embedded a diagram in the actual write-up of the information. Let me go to, let me see. And of course, the activity feed is here and been improved significantly from the last version, if you're used to the previous version of Innoslate. Of course, another new thing, of course, if you're not familiar with 4.0, the documents view. I mentioned that a little bit earlier. We have different documents available here, including a project plan. So here's a project plan showing those different aspects of it. You can go ahead and insert your diagrams and link them that way. Also, requirements diagrams. So let's look at maybe my verification requirements are here. So you can see those here with it. Click on it. Those attributes. Again, here's that result of the NLP technology saying it contains multiple sentences. Consider breaking it into multiple requirements. Is that a multiple requirement thing or not? You got to look at it and say maybe, maybe not. So you know, those are the things with it. So in fact, actually, I believe this one was originally had that, and it's actually been broken up now. So I have to rerun the quality checker. The quality checker is right here, so you just rerun it and see what the different things are. And of course, that problem went away. So somebody fixed it. I hadn't realized they'd fixed it. I'm sharing this with an awful lot of people. The sharing is up here. You can see lots of people actually have access to this. So never quite know when I run into this demo if what's going to be. Let's see, other things that are new. Diagrams view. Again, the diagrams, this looks a lot very similar to what I just showed you with the DODAF view. Again, we did this first, and then we created DODAF view from it. So you can see that kind of thing. And again, same idea, you have recently modified. And then if you want specific types of diagrams, for example, one of my favorites is the layer diagram. I can find it here. And so I can go right to my layer diagram and see it. So again, these are things that are kind of cool and available. I don't know if I mentioned Test Center, but here's Test Center. And so one of the things about that is that traceability matrix. So if I want to see the traceability matrix, one of the quick ways is the query vr.star, and let's go to verifies. And so I'm just typing and things just pop up. So there's my matrix that I've created. If I want to see the traceability, that's the traceability assist. Suspect, of course, is going to highlight the other ones that are in red. And again, there's if you notice the colors, I don't know if you can see it or not, the darker color means more likely this is a good match, and the lighter color, it means that it's less likely a match, perhaps. But again, those are just indicators for you. And if you see I'm hovering over this, I see the information about each of the items, the top item on the list here, which is my verification requirement 2, and appropriate markings. And then I come down here to line inspection. And so there's nothing in there about looking at the markings. So if there's actually something in the description field that said this includes inspecting the markings, that would show up very quickly as a good connection there. So that would probably give you a highlight of that. So again, it helps you do a better job of modeling. That's what we're trying to do with this. It's not a be all and end all for you. It's just a way to help you do it well. And again, last thing to show you directly is intelligence view. And again, the idea here is I've got multiple items here, and if I go through and say, yeah, they should be merged, I'd probably go look at each one of them individually first, and then say, yeah, I want to merge them, and have it merge all those things together. And so make sure that I wanted it to be the same item. So again, I have that ability to change those settings, make them, ignore them all, make them an error rather than a warning. So again, you have those different options for you to tailor it to make it how you want it to be. So again, that's a quick snapshot of some of the things we talked about in the slides. What I'd like to do is open this up now for the next 15 minutes or so for questions. And Elizabeth, do we have some questions yet?
We do have a few questions already. If you haven't had a chance to do so, use the panel on the right to ask your questions. Our first question is, have you looked at an interface to National Instruments LabVIEW? It claims to now have a graphical-based programming capability from the control system and other diagrams. It will generate C code. It also interfaces to MATLAB, but it has a built-in MATLAB capability as well.
Ooh, okay. In fact, we have. We just did a thing with Dr. Jerry Sellers. He's got a hardware in the loop simulator for a satellite system, and we just started that process of looking at it, and they made the minor mods you're talking about to LabVIEW, so it could take an input file from Innoslate. Our goal is to not do file transfers. Our goal is to ultimately use our APIs to move the data back and forth. And so that's ultimately what we're going to do to automate the whole process. But we did some baby steps for the conference last week at NDIA and showed doing exactly that. So yes, that is something we're in the process of working on and doing, and we'd love to do more of it.
We have more of a comment than a question.
Okay.
Steve, the NDIA MOSA committee created 2 cube-based measures similar to risk, one for openness and one for modularity. You may want to take a look at them.
Oh, okay, sure. And again, you could do that as labels on the diagram. So that would be a way I would implement it, probably in Innoslate, because we already have that capability. So you could filter, so you could just have those different ones be a label filter and use the same one. And if you don't like the 5x5, this can be adjusted. You can make this a 3x3. If you don't like even the wording we're using up here, please come in and edit it. You can even come in and change the colors of the squares. So this can be any matrix you want it to be. So it's very powerful.
Can you just do a quick view of the database tab just to get an idea of the level of detail required to develop the diagram? It might also help to look at entity view while you're there.
Sure, absolutely. So this view is the database view. Again, this lets you sort by just actions if you want. You can also look for particular labels. Let's see, scroll down and find a particular label you're looking for. Maybe I just want to find the activities. You can see very quickly how this works to filter things, and notice what it's doing up here. It's adding those things up into this search bar. Once you get the searches you want, oh, by the way, you can also come in and change the information that you're showing. So you adjust it here and you scroll down and pick what things you want to see. You can also make related information, and this does related information subsequent to each other. So in other words, if I've related this to another entity type, I could then take and relate that other entity type to something else. So you can create that matrix that way as well. Once you do that, you can also save the queries. And here's an example of one I did for requirements verification matrix. So if you don't want the one that I showed you before, here's another one. Gives you a little more detail. And again, this is all editable. All right, you can come in here and change what you need to change, make the adjustments to things as you need to do it. And of course, there always is the entity view, as Elizabeth was talking about. This is one view, hopefully you don't have to use a lot anymore. The one place you will use it for, though, is history. This is where we do the configuration management at the object level. And you may want to be able to use that to revert back to a previous version of something. And before you ask, we don't have yet the ability to do that all across the model at a particular time yet, but that is something we are looking at doing. So if that's something you'd like to see done, please feel free to add that to the send feedback form, because that'll influence our decision of when to get that done. Anything else? Next question.
We have a comment. Looks real good. It has come a long ways. Looks like it covers most and more of what we were thinking back in the 90s. And our next question is, can you talk about creating your own relationships/connections?
Oh, sure, absolutely. So relationships are all in here in the schema editor, so you can change and adjust that right here. So you could add relationships here. Oh, by the way, there's also where you can modify the workflow. I'm sorry, was that what they were asking? Or?
Yeah, they have actually a second part to it. Okay. For example, if I wanted to show an organization/asset would have operational control over another asset versus tactical control.
Sure. So again, you could do that through, I would probably go, sign me out again. Must be pushing changes to the cloud. Let's see, is this the right one? Yeah, this is the right one. Nope, okay, this is not the right one. Yeah, okay. Oh, okay. This is the DODAF demo. What did I jump into? I thought I had a different one here. So, well, let's use this one. This will work just as well. So here I am. Again, I can do that by a couple of things I can do. I can always add labels for that purpose here to distinguish between them, and then I can characterize these lines differently. If I want to have particularly color code them or something else, I could do that with it. So that's probably the way I would handle what I think I understood the question to be.
All right, our next question is, can Innoslate perform measurements associated with the interconnectedness of entities, i.e. graph theoretic metrics?
Ooh, so that is something on the horizon we are looking at. So we're not quite there yet, but the current conduits have attributes of capacity and latency. So you can actually use those to physically model your communications systems and things like that. We also have resources, so you can do resource modeling with it. So you can do a lot of the kinds of things you're talking about with this, but yeah, to get those specific metrics are something we'd be interested in. Again, I want to point you to the dashboard with the send feedback. Please, we always want to hear your opinions. We want your ideas. By the way, this is not for bugs. If you run into a problem, that's what support's for. Support comes with the tool. This is software as a service model delivery. Even if it's behind your own firewalls, you can call us for support. So please do not hesitate if you need help immediately. But for your good ideas, put them here, and that way we can rack and stack them against other users' requests and try to sit there and optimize our development cycle for be able to bring those good ideas into it. And in case you're wondering, oh yeah, everybody says that. Test Center was a customer request. The entire Test Center was a customer request. There are at least 2 diagrams I can point to that were customer requests, the layer diagram and the physical I/O diagram. So yes, we do listen to the customers and want to have your feedback and want your ideas, because if you have a good idea, it's probably something we do too, and we'd like to have we'd like to make sure that we're meeting your needs first, and so that's what we're trying to do.
Our next question is, there seems to be some sysml features missing, part properties and BDD. Is this because there are better ways of doing this within Innoslate?
So I think so. So many of the things that are done in sysml, we almost deem unnecessary. I hate to say it, and because the base system, the physical model and the functional model together do just about everything we think you need to do. particularly when you look at the simulation capabilities with the action diagram, having the ability to include the resource modeling as well as the branch assets, and then linking the physical model. You can have the IOs being transferred by a conduit. And so again, these are easy ways to link the models together, the physical and functional. So the physical model constrains the functional model, and then when you run the simulation, you get cost, schedule, and performance kind of results out of it. So you can see that. So that probably handles most of the needs people have. But again, it's something we can always talk about. If there's something you say, gosh, I really wish I had that. Wish you had that in your implementation of sysml, we're happy to talk about it and see what we can do. For example, here's the activity diagram. One of the ones people say oftentimes is, well, you don't have the border around it. Yeah, because that's really so 1960s. I hate to say it, because here's the activity diagram, here's the information about it, there's a whole description here. I can get all kinds of other information about this particular element as well. So there's a lot I can do with that in terms of being able to understand the information and working with it. And our whole goal is ultimately to replace having to print these out on paper. Hopefully give people access to the model using reviewer versions and things like that. There is a reviewer version now in 4.x, because this is actually, I'm showing you 4.1. We haven't officially released 4.1 yet. We put it out on the cloud, but we don't have the documentation out for it, so we haven't officially announced it. But here it is. So I guess I've just sort of announced it. Next question.
Our next question is there an offline version of Innoslate, not necessary to have it on the cloud, and how does one get it?
So we have the ability now to go to a personal computer, so you can create it in your own H2 database. I think it's a free database you could use. It's a SQL database, and we can help you get you set up with that. We do, though, require people to buy, I believe, multiple copies of the, so it's not an individual license kind of thing. Part of the reason for that is it is actually something we've shied away from, because the support requirements for desktop software is significantly higher than what it is for a cloud-based platform, where we control the back end and the interactions with that. So yeah, it's definitely doable though now today. Talk to sales.
Please, you can contact sales at innoslate.com, or you can give us a call at 571-485-7800, and that's something our account managers can definitely help you with. Our next question is, if I have a system already expressed in sysml, in Magic Draw, how much is involved in expressing it in LML versus LML Innoslate?
So we do have an importer for XMI. I will say it does an okay job of bringing in data from there. The problem we've run into with these tools is, since you can literally draw just about anything without rules, the diagrams don't come in as clean as you'd like them to be. And the other part of that problem is that none of these people have actually published their XMI ontologies. And so we had to write a different parser for each one. And so we're interpreting as much as we can from a limited data set. So we had to literally reverse engineer their XMI outputs to do this. So that's something we could improve over time. But however, I must say, because it kind of lets you draw anything without really following the rules, it's more than likely the diagram actually isn't correct. And you probably want to remodel it anyway in Innoslate. That would be my recommendation, because you will find that there are errors in the diagram. I know you don't think there are errors in the diagram. You can, and yes, you can draw diagrams with errors in Innoslate as well. That's the purpose of the simulators, is to detect those errors and help you correct them before they become errors downstream in the life cycle and become more expensive to fix. Sorry, that's honesty.
Our next question is, may you give a little detail on the workflow capabilities?
Sure, let's see if I can do that. Let me go back to import analyzer. Oh no, sorry, schema extender. There we go. So the workflow is set up so that you can add permissions. One of the ones we put in. So you have the ability to define the different states, the transitional states, and right now you could use a state diagram, but we don't have that linked up to this. Just to let you know, that is something we're looking at. Can we do that in the future? But we can't today. So that is one of the limitations, but you could use that to model what you want in terms of your state transitions for your process. And then you can then just simply assign those in an enumerated variable. So the status element in attribute in requirements, let me go show you that first because that'll make it make a little more sense. So let's go to requirement and look at the status, and there we go, enumeration. So the status has choices of, it's an enumeration type. It has a choice of draft, in review, approved, or rejected. So those are the different states it could be in. So now if I go back into my workflow, you can see those same states for requirements. I'm going to go to requirements. So there's always an initial status, but then there's draft, in review, and it generates these things for you: approved status, then rejected status. So then you go through and decide, well, who has permission to deal with it in draft. And again, if you're within your organization, you'll get the list of people who have access potentially to this. Then you will go and decide who gets notified for the next step. So this is how you go to that next step. So in other words, if it goes from draft status to in review, who reviews it? So that's my reviewers would be what I'd be looking for there. And then, oh, and by the way, notice this can be a team. It doesn't have to just be a person. So there actually are teams. So we have that ability as well now with it. Then you can decide if it's locked afterwards, and then what that next transition phase is. So again, you can see here I have from rejected and then in review. So I have both those options here, and that after the draft status. So you can see how that works with it. And so yeah, so it defaults initially into draft, and then of course you go and do that note those next transitions from draft to those different phases. Okay, so I hope that makes it a little clearer how that works. By the way, these notifications will be emailed to you unless you're on the GovCloud server. The GovCloud server does not allow an email server, unfortunately, so that is a limitation of that environment.
We're getting actually a few questions off of the earlier question we had about having an on-premise tool. I just want to clarify real quick that you can we have Innoslate Cloud, and that's our cloud tool. That's our public cloud tool. We also have Innoslate Enterprise. You can put that on your own server. So that's our on-premise solution, and that'll have the security of your firewall. And we're also available on Amazon Web Services, Amazon GovCloud. We're also available through NSERC as well, and that's Zipper and NipperNet. And of course, if you have more questions about this, that's something our salespeople will be very happy to help you with. So feel free to give us a call or email us at sales@innoslate.com. So I just wanted to really quickly clarify that and move on to our next question. Has the JITC Test Center used it? Sounds good for a lot of what they do.
JITC. I don't know if they're using it or not. I must say I don't know all our users, and part of that's because a lot of people are using it on NipperNet and SIPRNet through NSERC, which is also the AFCERC, the Air Forces. So there are different groups using it. I was surprised at some of the people who were on it, but I don't think JITC is yet. I know I wanted to talk to them about that. I saw a presentation from somebody at JITC and mentioned it to them that we might be able to connect up on that. So, but yeah, this would certainly be very valuable for the work they do at JITC. and many other places.
Not for this training session, but just wondering if Innoslate has heard about the Intertax and Syndia 3.2. Syndia model is capable of connecting to various tools to share data between tools for your information.
Mm-hmm. Yeah, I think I've heard of that one. There's a bunch of those we're looking at like that. Right now, our approach has been to do more point-to-point integrations on key tools. That's been because we think that's a better way to work through the API sets that way, but we certainly are always looking at those other options and seeing if there's ways we could do something like that.
Our next question is, can you demo the automated document creation, please?
Oh, okay. So to create a new document, you just simply go and, oh, I'm sorry. Yeah, there's two different types of things. So if you want to create a new document, here's a template. There are various templates available for each of the different types. So you could then, you just start with the type, the document you want, give it a name, test ConOps for fun, click next, and then you can have the option of blank document or pick these different document types we've created templates for this. Now, if you have your own, we recommend you build your own within the tool and then upload those as you need to as an XML product in the importer. So again, that'll give you those different aspects of it. Let's do the DAU one for fun. And so here is what that looks like. So it's generating that document. You can now start building the information here and work with it. It's all editable. Here's where you insert diagrams, images, tables, links, hyperlinks. So again, you can start really authoring it. We've got bold, italics, underline. There's strike-throughs, superscripts, subscripts, different types of formatting kind of capabilities, things like that. The output ultimately you might want to be using is going to Word. So we have a document output for that. But we also have CSV tables and things like that. And also some of these other diagrams that are of interest and use potentially for you, depending on what you're doing. In fact, I didn't mention this, but the reports button is in every view, and you use whatever report makes most sense. We also have the ability from the actual action diagram. You can actually, you have to go down a level right now, generate an asset diagram or requirements from that. I'm not personally happy with that at the moment, and so we're looking at some other better ways to do that generation of a requirements document from other views. Particularly the asset diagram, I think, is where we're going to target next and see if we can't do a better kind of document. But we do have them, and it will create that requirements document for you from the information. I believe I have an example of that here somewhere, but I don't remember exactly where it is. So I'll be struggling to find it if I don't know exactly where. Oh, I guess this is it right here. Yeah, this looks like one that was generated from it. So again, you can capture some of that information automatically from it. Yeah, that looks like that was generated from that tool. Again, I think there's more information that needs to be in this to have a more complete actual specification from it, and that's what I'm looking to do. Next question.
That's all the questions that we've received. Thank you, everyone that asked us questions. We'd like to thank you again for joining us for today's webinar. Make sure to join us next time for our next webinar using Innoslate Test Center for Integrated Lifecycle Verification and Validation Planning and Execution on December 13th at 2 p.m. Eastern, and that's a special webinar from Dr. Jerry Sellers. As always, we will always send the recording and slide deck to everyone that attended today. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.